In this episode of Home Theater Geeks, I chat with Anthony Grimani about the speakers he recommended I put in my home theater. So stay tuned.
Podcasts you love.
From people you trust.
This is TWiT.
Hey there, Scott Wilkinson here, the Home Theater Geek. In this episode, I'm going to talk about the speakers in my home theater, which were provided by Anthony Grimani. Now, he's been a guest on the show before. He's an electrical engineer that specializes in audio electronics, acoustics, and speaker design. He's a home theater designer as well, and he's the head of Grimani Systems, company that makes speakers, which we will be talking about today, PMI Engineering, which is an engineering and consulting firm for designing acoustical spaces. And he's also the head of MSR Acoustics, which is a firm that specializes in acoustic treatments. We're going to be talking about that in the next episode. But for now, we're going to be talking about speakers. Hey, Anthony, welcome back to the show.
Hi, Scott. It's good to see you again.
Good to see you too, as always. Now, in previous episodes, I've talked about other aspects of my home theater. For example, in episode 392, I talked about the special paint, the very neutral dark gray that I put in the room. In episode 455, I talked about the TV that I chose for the room, the Sony 77A95L. Talk about alphabet soup. A QD OLED, which really looks fantastic. It's a wonderful television, and I'm really happy I put that one in there. But now it's time to talk about the speakers. Anthony, I decided I wanted to use your speakers in my room because every time I've heard them, whether it was at Cedia or in your showroom, they really sounded great, very natural sounding, and very cohesive, with a high dynamic range. Not that I like to listen to really loud music, but I like to have that dynamic range because music and soundtracks have a wide dynamic range. And if you can reproduce that well, you're really ahead of the game. And I've always thought your speakers did a great job at that. So I contacted you to discuss it, and here we are.
Thank you.
Now, my room is not ideal, as you know. It's open on one side to the kitchen, and I have a floor plan diagram here to show you, to remind you of what the problem is. And as you can see here, I've got a screening area on the right, and 3 of the walls are closed in. There's a sliding glass door on the side and a window at the back, and it opens out into the kitchen. Now, this actually works for my wife and I, because as we're in the kitchen working on meal, we can see the TV very nicely. But it doesn't work so great for, a dedicated home theater. And Anthony, you've worked probably on plenty of these kinds of rooms before, right?
Right. These mixed use environments that I call the media lounge, which are not idealized for any application. They if you're just happy to have picture and sound, who cares? But what we're trying to do is to reproduce the picture and sound that the director intended, reproduce the excitement, reproduce the feeling of being inside the movie, not just observing it. Yep. And it gets challenging. Yeah. So you got to put some extra creativity into it, and we did that. You guys all need to know that Scott and I went back and forth a number of times with ideas of how to skin this cat. By the way, no cats were hurt in this process. But about how to arrange the acoustics and the layout and everything so that when you're in non-movie watching mode, the room is usable and pleasant. And then when you go into movie mode and you hit play, it's pretty stunning.
Yeah, and it really is. So tell us how you approached speaker placement and selection.
Yeah. Well, I beat you over the head over what you need to do. No.
Yes.
So it all starts with what's the target. It all starts with, hey, the front speakers should be, at about this angle from your main listening position, which happens to be around 45 degrees subtended angle between the left speaker and your head, and the right speaker in your direction would be the other way around, left and right. It starts with that. The center speaker should be at the same height, except that you've got this beautiful TV. So you're going to put the speaker below or above, and we have to decide which one is the least bad in terms of the perception of it. We have a technology now, by the way, on larger screens that allows us to project the sound onto the screen. We call that reflectance, where there's actually a gizmo put over your head that acts. Now that on a video wall, not that there's not a video projector there's room to put an audio projector. We bounce that off, but it wouldn't have been appropriate for your room. So have to figure out where's the least bad compromise, or the best compromise.
Yes.
And then we know that the surround speakers, ideally, they want to be, slightly behind you, up 15 degrees. Well, you couldn't do that. On one side, it's air. And on the other side, there's either a window or a piece of wall, but it doesn't match that. So
there's a window on the most of the back wall and a sliding glass door on the side.
Yeah. And so we started with, hey, here's what we want to do. Okay, can't do that. What can we do next? What creative solution can we do, knowing that the target is this? How can we do something different that is close enough on the target? And that's what we do throughout. So it's like, interestingly enough, like all engineering processes are, whether you're designing a car, a rocket, a plumbing system for a sophisticated building, there's always all these different things you have to figure out, sort of like a Rubik's Cube with another 6 dimensions on it that you need to work through to go, okay, well, if we do this, then it will affect that and this and that. And we finally got there.
We did.
Do you want to get into the specifics of where we ended up putting speakers? Do you have the plan?
Yes, I do.
Am I ahead of myself?
Well, you're a little ahead of yourself
Okay.
because... Oh, hang on a second. Here we go. Yes, I wanted to first start with the speaker selection.
Yeah.
Which, because it's a relatively small room, we went with what are for Grimani Systems, relatively small speakers, the Rios system.
Right.
Which come in several sizes.
Yeah.
There's an XL and an L, and we chose the S, the small, because it's a small room. In fact, here is the speaker that we used for the front, right, and left. Correct.
So we make a range of speakers that all have the same basic quality, and actually they have such a good matching quality that you could use an S, which is this one for small, on the left, together with an L, which is a large on the right, as a stereo pair, and they would produce a perfectly good stereo image, which is kind of odd. They're different speakers, different drivers, but we match them all in their design and engineering to where they're completely complementary. I'll explain later why we do that. It's not just an exercise in futility. There's a good reason for doing that. So then you say, well, what speaker do you need? Well, you need enough to drive the horsepower in terms of sound pressure level you need for your room. So in your room, you're sitting so many feet or meters away from the speaker, and the space is this many cubic feet or cubic meters of volume. And we know, back to the standards where I was saying, the speakers should be here. Well, we also know that the peak sound level you need to achieve in the case of a movie soundtrack is 105 dB. That's like the loudest peaks in any of the 3 front channels. And so we match that requirement with what your room is, what the acoustics are, how far the speakers are. And we go, given all of that, you need that much horsepower. I guess it would be the equivalent in a car of figuring out how fast you want to go and how big of an engine you need given somewhat the weight, but also the CX of the car, how well it cuts through air. So it's an audio equivalent of that for cars. A lot of people understand cars much more than they understand electroacoustics.
Right.
Besides, I like cars. So
indeed. So do I.
So we figured out, given how far you are from the speaker, how loud you want to listen, and actually gave you quite a bit of headroom over that you would be fine with the small size speaker. And in the case of our company, we actually have 3 different form factors for the small. We have one that's like this one, that, and then one that's a little smaller this way and deeper that way. For you, we chose what's called the Rios SNR, small, narrow, recessed.
Right. Which, if we look at the picture one more time, we'll see this is taller, but less deep.
Correct.
And it looks like to me like it's got a compression tweeter in a waveguide.
It's actually not a compression tweeter. It's a very high quality European-made dome tweeter, silk dome tweeter. That's mounted into a waveguide, and that's kind of unusual. Usually, horns and waveguides have compression drivers in them, and
right.
No, we're not doing that here. We don't need, in the case of these speakers, we don't need the sound pressure level capability that a compression driver gives you. Mm-hmm. Instead, this particular one, it's made by Audax, has enough sensitivity, and when it's loaded in that waveguide, which gives it a little bit more headroom, actually quite a bit more headroom in its low frequency region, around 2 kilohertz, it produces plenty of sound pressure level. And I think I demonstrated that to you when it all got calibrated. I went like, well, let's turn this up to 11. You're like, okay. And I think your wife came running down from the other side of the house going, you're not going to play it like that all the time, right? No.
No, she did do that. I remember that very well. Yeah, and I'm not a fan of really loud soundtracks. I know plenty of people who listen at what's called reference level. Right. And it's just too loud for me. It's just painful. Yeah. So I'm never going to listen at that level. So again, what you provided is just fine. Yeah. So those were the front, right, and left. The center is the Rios H2, and we'll take a look at that. That's got 2 mid-range drivers, and is it the same tweeter? It
is at the time you got it. Interestingly enough, there was a transition, but on that one, it's the same tweeter as the Rios S. Mm-hmm. The 2 drivers that are on either side are really mid-ranges. We call them woofer mid-range, whatever. They play down to 80 hertz, which would qualify them as woofers. They're, interestingly enough, they're configured in a 2.5-way crossover.
What does that mean?
Without which that speaker would not sound very good. So if you were to do what most other manufacturers do, which is they connect those 2 woofers together, either in parallel or in series, but they're playing together. Mm-hmm. At some frequency, you would get what's called lobing. The sound right in front, instead of being a nice wide dispersion, nice bubble, it would start to create these 3 or 4 or 5 leaf clover radiation patterns.
Yes.
And that's because when the 2 woofers are right in front of you, you're hearing all the sound adding correctly to you. Mm-hmm. But if you go off axis, which I'll do by turning myself, that woofer reaches you before this one. Mm-hmm. And on some patterns of the wave, when the waves are leaving like this, but what that one reaches you going up, the one right behind it may be going
down and they cancel each other
like this. And there could be a cancellation. And I'm going to go out on a limb. All of y'all, this is proper American, all you all who are listening, if you just learned one thing from all this, that is to watch out for all of those quote unquote center speakers that have 2 woofers straddling a single tweeter. If they're designed in the most basic way, they're going to sound okay on axis, but 1 seat to the left or 1 seat to the right, you'll be missing mid-range sounds from this interaction, which means that dialogue clarity is going to suffer. It's going to be like, well, I hear him talking, but I'm not really sure what he or she is saying. So that would be a regular 2-way system with 2 woofers to make it look symmetrical. I see that somebody's using a phantom center. I want to buy a phantom center somewhere. Can you tell me where to buy those?
So how does the 2.5-way work?
So 2.5 is this, and we're not the only people doing that. First off, it costs more. No, Ozark Chief, you should say, I can sell you a phantom speaker right after I sell you a bridge Anyway, so 2.5 way, the idea is this. You have two woofers in order to have good bass headroom, right? That's why you need the cone area.
Right.
Oh, he has swamp lamp too. Let's talk about it. I think swamps are really cool. Does it have alligators in it? So
by the way, Tony is responding to the chat room here.
I should turn off the chat.
You should turn off the chat room, right? So we can stay on track here.
So you need two woofers in a speaker to have bass headroom, to have like more power capability, more horsepower at low frequency. But if you make those two woofers work together all the way up to the mid-range and the higher frequencies, you're going to get these interactions. At low frequency, there's no interactions because the waves are very long, so they don't really interact off axis. But as of about 800 hertz or 1000 hertz, there's just massive interactions. So in a 2.5 way speaker, what one does is you use the two woofers together, and at some frequency, usually 200 or 300 hertz, you drop off one woofer and you let the other one continue on up. You have to tailor the frequency response of all this because you got two working together and one goes away. So this one suddenly has to play louder. So the crossover is a little more complicated. But when that other one that's playing alone hands off to the tweeter, there's a very small displacement between the woofer and the tweeter in terms of space, and there's less horizontal lobing. It's called lobing. Interaction.
Right.
Bad sound, bad juju in the sound.
We really don't want that.
I'm going to say this one more thing is we do this easily because all of our amps use digital signal processing. The crossover is done in the amp. We can play all of these really cool games with the electroacoustics of building a 2.5 way speaker without a really complicated crossover board that chews up a lot of power. I know we're going to come back to talk about that.
We're going to come back and talk about amps in a little bit. So put that on the back burner for the moment.
Over there.
Thank you. I appreciate that. Okay. So we've taken care of the front three, left, right, and center.
Yep.
Now we want to talk about the surround, and there are the Rios W,
right?
Which we see a picture of here. Same tweeter or not the same tweeter?
Same tweeter. Essentially all the same componentry as a Rios S. But two core differences. One is that you'll see the head, if I can call it that way, is canted back about 35 degrees. And the waveguide's turned around. So the sound actually, if you were to project a line on that sound, it would go up 45 or 50 degrees from that main direction where the woofer is. And those were designed for putting on a ceiling. And with the angled waveguide, we call this W for a wedge, pointing over at you. So we put those on the ceiling. Now, ideally, if you had a dedicated room, we would put two more of those Rios S or SNRs on your sidewalls here. Okay, and they'd be up at about 15 degrees. So we couldn't do that, like we talked about before. There's a hole there.
Right.
So what we did instead is we put them a little further out, up this way, angled to where the sound, instead of coming at 15 degrees from you, which is the cinema standard, there's a lot of talk about how high up the speaker should be. Simply 15 degrees up from
ear height,
horizontal light between your ears, which typically translates to about 2 feet up above your seated ear height, depending on how far they are. So what we did instead is we said, okay, well, we can't put a speaker there, but let's go ahead and put a ceiling speaker up further on that same projection up on the ceiling. And we cheated it a little bit. So you're at 20 or 25 degrees. So the sound of that speaker, while it's not coming from the wall at you, it's coming from the ceiling just a little bit higher up. And in the end, your brain doesn't know that it's on the ceiling versus the wall versus hanging or on a stand. It just goes, the sound's coming from over there, and it worked fine.
It does work fine, and I'm going to talk about that here probably in the next episode more than this one. Finally, I just want to talk about the subwoofers. There are two. They are the Zeta. Your company, Grimani Systems, makes a number of subwoofers. This one is, I think, the small one.
It's the second from smallest. The smallest one has a 10-inch driver and a pretty small cabinet. This is a 13.5-inch driver in a pretty slim cabinet. It's about 5 inches deep, 5.5 inches deep. It's pretty tall. It's only 4 14 inches wide. And it's basically designed just like you did to tuck it up against the wall in the front or the back or the side or the ceiling or wherever and not take up too much room.
Right. And I've got one in the front and one in the back. Is it a sealed cabinet or a ported cabinet?
It's a sealed cabinet.
And why did you do that?
We're big fans of sealed cabinets for lots of different reasons. There's no doubt that by doing a ported subwoofer, you can get a lot more sound pressure level in the bottom octave. But then there's a lot of side effects. So that medication that is a port introduces too many side effects, distortions, interesting issues around standing wave control. When you turn up loud, the bottom octave actually can go into a different phase response in the direct. I mean, it gets complicated, not worth it. Our strategy instead is to put sealed cabinets with drivers that can take a lot more power than you would need for a ported unit and basically drive the snot out of it. And just because, the motor structure is big enough where you normally would just need 300 watts to get plenty of sound pressure level, where in a sealed cabinet, you're going to have to do, if the cabinet's small enough, you're going to have to rise up, you put some equalization on the bottom octave. And I'm drawing this in your direction to compensate. And then the side effect is you need a bigger amplifier, which these days is pretty cheap. Getting 1,000 watts is not very expensive. And you need a driver that can take more power and more excursion, which that is still expensive.
It's funny, a powerful amplifier, which is essentially digital technology, it's electronics anyway, relatively cheap these days, but a driver that can handle it, which is an analog device, still expensive.
True. It's an analog device with a lot of metal, magnets.
Yep.
It's interesting. Just I can talk about this. That law that every few years everything gets down to half the price, and it happens in computers and electronics, all this other stuff. Hasn't happened with cars, or maybe in a way it has. On drivers, ultimately it's still metal. Or aluminum, but it's still basically metal work with magnets and coils and things that over time can't get cheaper. The manufacturing processes have gotten more automated. So today you can buy a driver of a certain quality for less, that same quality for less money than it cost 20 years ago, just because of the advances in reliability and manufacturing efficiency. But it's not nearly the same drop as we've seen, across the board in electronics.
In electronics, right.
Scott, I wanted to mention one thing. In your room, you have surround speakers that what I call the sides. You also have backs.
Correct.
So the solution for the backs is the same as done for the sides. Normally, you would want on the backs, on the wall, again, about 15 degrees up from you,
right.
Not spaced too far apart. We just replicated that by just taking those lines and going, well, we can't put them there. Well, let's put them up on the ceiling as close as possible to the same vector direction.
Here's the front of the room. And the speaker placement that we see here is the front left and right and the center, with the subwoofer on the floor, tilted on its side from the way it was oriented in that photo, and two overhead speakers. I think those are the Atmos speakers.
What I call the top channels of Atmos. Yeah.
Top channels, yeah. And if we look at the next one, 8, we're going a little out of order here. Here's a side view with your lovely drawing of a person.
Standing man, we call him.
Standing man. And we can see the subwoofers on the floor, one in the back and one in the front. The front speakers there on the right. And then we can see the overhead speakers, which the ones towards the front of the room are the actual top speakers that are going to reproduce the Dolby Atmos or DTSX overhead channels. And then the middle one there is the side channel, side surround, and the back one is the back surround. And if we look at the next drawing, we can see that same thing from overhead. So here you can see, and you've done, very accurate angle drawings, and the side surrounds are pretty far apart and a little behind the seating area. So this is part of the service you provide, and really beautiful, I thought.
Thank you.
So all the speakers of the surrounds and the overheads are on the ceiling, which, that's not typical. But again, we're dealing with an atypical room, and we had to make compromises, and we had to do things somewhat differently. Now, one of the really cool things about your speakers are that they're all powered. They're all active speakers, but unlike most such speakers, which have the power amp in the cabinet, yours, at least in my case, the amplifiers are external. They're rack-mounted little amps. Is that true of all your speaker models?
The great majority of them. When we came to market 8 years ago.
8 years ago.
I know. It's like, what happened?
Oh man, I remember when you started, and I was blown away. But that was 8 years ago.
8 years ago. The speakers you heard at that time had the amplifiers inside the speakers, the way you build the majority of active speakers.
Right.
And there were already, and there are since then, some products out there in which here's a speaker, here's the dedicated amp for that speaker. Mm-hmm. But we thought it would be better to just have the amp in the speaker. And we got actually a fair amount of pushback from integrators on that. That said, you know what? I really like all the electronics in the rack. I like to manage it all in the rack. If there's a network connection, like our speakers or our amps are all network connected, which we'll talk about later, I'd want that all in the rack. So the market spoke to us. The majority of the things we're selling are through integrators, and they said, we'd rather you rip that amp out of those speakers and put it in the rack where we're used to putting electronics. And it's like, okay. So I would say today, 80 to 90% of what we sell is active. Well, they're always active speakers, but the amps are outboard. They're dedicated for the speaker or a pair of speakers, or 4 subwoofers could be driven by one big amp, for example. But the amps are in the rack like they are in your room.
Right. And I have a picture of the amps in the rack that I can show people. These are from a company called PowerSoft.
Yep.
And this particular model is the Mezzo. And we mounted them. You helped me do this. Put a little space between them. These are all Class D amps, right?
Yeah.
So they're
Class D plus. They take Class D quite a bit forward in the state of the art. They sound audiophile, which is a really arrogant thing to say for a black box that doesn't look like anything special. But we did some extensive listening tests against known audiophile standards, and on a blind A/B, my partner and I couldn't tell the difference between one of these, and I won't name any names, but recognizable brands of amplifiers, Class AB. We didn't have any Class A amps in the listening test, but on a one of those stereophile or equivalent, top-rated amplifiers against this, there wasn't a discernible difference under normal conditions. So very good amps.
Yeah. And most of them, if we go back to the picture, we can see they're organized. The top one, there's only one up the top, and that's the center channel. And then the next row down, the left one is the front left and right. And then the next to the right of it is the overhead left and right. And the one below that is the side surrounds, and the one below and the one next to that is the rear surrounds, and then the two at the bottom are the subwoofers. So right. Most of these, except for the bottom ones, are. Let me look up the number here. Mezzo M324A plus.
Exactly. 4-channel
amps. They have they output up to 80 watts per channel, and I found this very interesting. They keep the same power rating whether you're driving 2, 4, or 8 ohm speakers.
Right. Truly a power amp, right? Regardless of the load, it's delivering the same combination of volts and current.
Mm-hmm. Which I found very interesting.
Yeah. So there's another really interesting thing about those amps is so You can think of them as 80 watts per channel, or you can think of them as a brick of 320 watts. They implement a technology that's now appearing in some number of professional amps, which is power share. Mm-hmm. So if you drive one channel alone, like if you drive output 1, you can get 100 out of the 324. You can get 160 watts out of output 1. Mm. If you drive 1 and 2 together equally, they go down to 80 watts. If you turn 1 off, you go back to 160. So it's not like they're bridging. It's just that they're sharing the power available from the power supply and the current into the output devices. So
it depends on which ones are drawing power.
Exactly. So in your case, I think I showed you this. Even in the loudest scenes, it's always the woofers that require the highest voltage for power. Mm-hmm. And so we hook these things up to where each channel pair, there's a woofer on one and a tweeter on the other. The when the woofers could be asking for 80 watts, the tweeters are asking for 1 or 2 watts. That's what normally happens with the sensitivity of these things. So the woofers can get more than 80 watts. They can actually go all the way up to 140, 150 watts while the tweeter is still only asking 1 watt. So that's one of the reasons we use these amps is that they're intelligent. They distribute their power the way you need them, and they sound really good. They don't use a lot of power. And then there's one more feature, which is they're completely digital signal processing enabled. We can configure a bazillion things in those amps to implement the crossover between the woofer and the tweeter, adjust the frequency response of the speaker to the room, which is a necessity. I don't care how good or expensive of a speaker you have or how much you treated the acoustics. The room is always going to have its own thumbprint. We'll talk about that next week. And you can neutralize a fair amount of that thumbprint through the signal processing that's available in these amplifiers.
So I want to make clear to everybody that each of these amplifiers is 4 channels. And each channel is driving one driver in the speaker. And in the case of the front, right, and left, and all of the surrounds and overheads, there are 2 drivers. So with 4 channels, you can drive 2 speakers.
2 speakers.
Two drivers in one speaker and 2 drivers in the other speaker. This is often called bi-powering.
Or bi-amping, bi-power.
Bi-amping, right.
Yeah. But that's one of the benefits of doing an active speaker is rather than do the crossover as a passive device inside the amplifier, inside the speaker, that essentially works by sorting out what's the high frequencies that have to go to the tweeter and what are the low frequencies that go through the woofer. But it does so by essentially applying the brake, if you want to think of it that way. And you lose between 3 and 6 decibels of the available power. That's half the power or a quarter of the power that gets to the drivers compared to what you put into it. Instead of that, we're doing that actively in the digital domain ahead of it so that all the power in the amplifiers can get to the drivers. You get a lot more sound pressure level from that.
So it's much more efficient.
Way more efficient.
Yeah.
We can also adjust the crossover way more precisely. With passive components, there's only so many things you can do before the board has 500 parts on it. With a DSP signal control, you can adjust all kinds of different things in the frequency and the time domain. Let's say you really wanted the impulse response of the speaker, which is how it behaves in the time domain, to be linearized. You can do that with a DSP processor that you can't do in a passive crossover.
A passive crossover, right.
I should mention that the subwoofer amps are not 4-channel. No. They're both 2-channel amps, essentially 600-watt bricks, one to drive the front subwoofer, one to drive the back subwoofer. They are 2-channel amps, but since they're only driving one subwoofer each, they're acting like a mono block each.
Right, exactly. And they are they're 2-channel amps, but because of this power sharing technology, all the power goes out one
port. Yeah.
One port. Yeah. And the center channel is using one of these Mezzo M324s to tri-amp the center channel, right? Because it has 2 mid-range woofers and 1 tweeter. So it has 3 drivers.
Exactly.
And once again, the power sharing can be used as it's needed. I mean, that's just a beautiful thing. So let's see. Oh, I wanted to show you the wiring diagram. Show everybody the wiring diagram, which is very nice. Again, a testament to the precision and care that your company and you particularly put into this. Everything is very well thought out here and clearly delineated, which really helped my installer.
Right. Yeah, for every system we sell, we produce a wiring diagram that shows what port goes to what gets connected where. So I sometimes joke that if we didn't do this, we'd have to take the phone call anyway. So we may as well do it ahead of time, and everybody is happy because there's a reference. This is what you do. Otherwise, even though there is an installation manual that goes out with every speaker, every amp. You know how it is. People don't like to read manuals. They want diagrams. They want pictures. They want something that helps them across.
Yeah, it's true. It's true. So, so that was the wiring diagram. The placement we looked at, and I decided I wanted to mount the speakers on the walls and ceiling rather than in. These speakers could be in wall, right? You could cut a hole the size of the speaker and mount it flush to the wall, right?
Yeah. Every single one of those has the ability to be mounted flush to the wall with the grill that sticks out a little bit because it gets snapped onto these flanges that get put around the speaker. Mm-hmm. We also have a recess mount where we provide a plate that's routed back, so the speaker ends up being about a quarter of an inch back from the face of the sheetrock, and you put a grill inside there. It does mean that your wall needs to be able to take it. So the speakers are all 4 inches deep. You can put a 4-inch speaker in a regular 2x4 wall, but you can't recess it. There's no room left. Mm-hmm. So for a recessed installation, you need to make sure you have a 2x6 type stud or deeper.
Mm-hmm. Which I didn't have. I had 2x4, and I decided I wanted to put them on the wall instead of in the wall for ease of installation. I really didn't want to cut those big holes in the sheetrock and do it that way. And I don't need that for my own aesthetic purpose. I can be perfectly fine with having them on the wall.
Right.
So the installation was done by a guy named Greg Wint and his assistant Mark from Wint Audio Video Solutions right here in Santa Cruz. And I have a couple of pictures of that. Here they are installing some of the ceiling speakers. And they, your directions were very clear. I think we only had to call you a couple times.
Yeah.
And you can see here in this picture, the window. We opened up the window and the sliding glass door to provide more light for the installation. But you can see how it would have been difficult to put a rear surround speaker back there on the wall. There's another picture of them doing that.
Notice the gray walls. Thank you for doing that.
Yes. Well, I consulted with you before choosing that paint as well. That's a very specific Munsell gray, very neutral.
Right.
And there are also a couple of pictures in this sequence of Greg taking the speaker wire, which they routed through the walls, and they come out these plates that you see on the left here. And he had to put little connectors at the ends of the bare wires because the amps have a kind of a special connector. They're not standard binding posts or banana plugs or anything like that.
It's called a detachable Phoenix connector. Mm-hmm. And it actually makes life easier in installation because, like you saw in this picture, you're working on the connector right there, in the comfort of your crouching position. When it's time to connect it, you just go click.
Click.
Right. Otherwise, you'd be like with binding posts on the back. And by the way, by the time you have 4 or 8 channels of connectors, trying to put binding posts or the little push terminals is just it just doesn't work. It's just
in this picture, he's doing the snake, which goes between the processor and the amps to feed the amps. And he's doing that same thing, but at the comfort of the island in the kitchen.
Right.
So that was very, very clean and nice. And then finally, you came over, flew down from your home in Northern California to do the calibration, and I got a couple of pictures of that too. So we can look at that while you tell us the process.
Well, number one in the process is to look as geeky as possible and put a light on your forehead.
Right, of course.
Otherwise, you don't look serious. And if I could, I would actually wear a lab coat with a pocket protector, but it was too warm.
You know what? I have a lab coat. I should have given it to you.
So this is a cool process. So I'm sitting there with my improvised desk, which is one of your stools.
Yes.
On that desk is my laptop. If you actually, I'm going to actually do a little tour. If you look at the first cable on the left of the laptop, which is this relatively large black and white cable, that's
sort of braided.
That's an HDMI cable that's leaving my laptop and going to your surround decoder. Mm-hmm. My laptop is running Room EQ Wizard, which is a program I absolutely love. I've got lots of other choices of analysis and signal testing, but I've settled on Room EQ Wizard a while back. If you guys want to do calibration, that's the tool to use. It's a free download, but please give a donation between $50 and $100 or more to the company who designed this or the guy who designed this, because he is really a jewel of the industry. So anyway, so there's a HDMI cable that goes to the system to feed it a left, a center, a right, whatever signal I need to be is what's called exciting the speaker with. It's an excitation.
Hey, I'm all about exciting the speakers.
Yeah, it's really exciting. Let's go back to that picture and I'll continue. So then there is the next wire there is a network connection. So I actually have a dongle there to go from the USB connection to a network connection. That network port is going directly to the switch onto which are connected all of the amplifiers. So the amplifiers, again, they're all digital signal processing, but you address them through network, through IP interface.
They all have an Ethernet port, and you connect the Ethernet port from each amp to an Ethernet switch.
Yep.
And you can access all of them.
Right. And then the last cable that actually expands out to two other things. On the other end, you can't see it, but it's probably going to what's called my interface box, which is the thing that converts analog signals into digital through USB. Now, somewhere else here is a multiplexer. I'll explain that in a second, but I'm going to go to the other side. You see 3 microphones here. Mm-hmm. The 4th microphone is somewhere probably behind me. So the process is to set up 4 microphones at the various seats in the room, various locations where you want to measure. You plug those into a switcher, a thing that allows you to select microphone 1, 2, 3, or 4, or select any group of microphones. You can do 1 and 2, 1, 2, 3, 4, and the multiplexer just switches around them at the rate of about once a second. The output of that signal, which is an analog signal, goes to the interface, the actual analog to digital converter. The output of that goes into the laptop. And I'm typically using what's in Room EQ Wizard known as pink PN, pseudo-random noise, that's feeding 1 speaker at a time. I'm measuring it out of the 4 microphones, but it's switching between the 4, and I have the analyzer set for averaging over between 8 and 16 seconds. Usually 8 is enough. And so I'm looking at the average of what the sound character is at those 4 microphones. I'm feeding a signal into the speakers that's called pink noise. It has equal energy at every frequency. Mm-hmm. And I want to adjust the equalizer in the amplifiers until I get that back into the analyzer.
So now, you're feeding them equal energy at every frequency. Yep. You want the sound coming from the speakers to be the same. Right. To measure the same from those microphones.
However, this is where the things get tricky. where just like in all fields, there's the basics and there's what happens, at the 101 level and the 200 level and at the 400 level. Unfortunately, the way those microphones work in the room with the sound pressure of the speaker and the dispersion of the speaker and the sound power of the speaker and the reflection decay time of the speaker and the way an omnidirectional microphone, which is what one of these are, they pick up sound in all directions, is as compared to the human ear, doesn't quite translate. So if you actually were to adjust everything until you got a perfectly straight line, what people call flat frequency response, a straight line between bass and treble, the sound's going to be really edgy and uncomfortable. And this has been amply documented for decades by many people, including Dr. Floyd Toole and his acolyte, Sean Olive, who have done a lot of work on, what do listeners hear, why, what's going on. And really, it's a combination of a little bit of listener preferences, but much more of how an omnidirectional microphone in a room with a sound power that's not flat with frequency, with speakers that are not flat sound power with frequency, what it is you got to do to make that match what you feel sounds good. And really the answer is, rather than a perfectly flat line, it's a line where there's a gain in the low frequencies from 20 hertz to about 100 hertz of about 4 or 5 dB. And then it rotates down a little bit to 200 or 300 hertz. And then it's about a flat line with a slight depression. And then at some high frequency, usually 6 or 8 kilohertz, it rolls down a little bit more. That's what's known as the target curve. Which doesn't apply to every room. It's a good average, but that's what I do is I start off by adjusting the bands of equalization that are in the amplifier until you yield, those 4 microphones measuring the room on average yields a response that is a target curve. I would call that level 200 or 300 of how to do this. Then there's a level 400. Yeah. Which is, even though that target curve has been amply documented for decades now, it's a target curve. It's an average. So if I just left it that way, you would go, that sounds great. Thank you. It's amazing. But I may still find that, the bass is a little loud or a little shy, the mids, I'll find from listening to program material repeatedly, I'll find that we need a little bit of this tweak or that tweak. And you remember doing that, where we sat and listened to a whole bunch of program material, reaching over for something that I want to show all y'all. But not only do we do it subjectively, where I don't ever want to do on my own without an agreement from somebody that, it's a little too bright or a little too dull. We just listen to 6 or 7 pieces of music that we are both familiar with, or movies, and I equate this a little bit to following a recipe to a T. You follow a recipe, you cook it exactly that way, and you know what? In the end, it may just lack a little salt or pepper. Or cumin, or whatever it is that and then you give yourself the permission to add a little bit. By the way,
season to taste.
Of course, the problem is if there's too much salt, I don't know what to do. I've read people say if there's too much salt, you do a bit of this and you add a little bit of that and whatever. But I do want to point out, and you may remember this, that part of the process of that 400 level of the seasoning to taste, I like that. Involves these little guys that you've seen me wear a lot. Yeah. Right? On earlier of these webcasts, I wore these instead of listening to speakers. But these are what's called Etymotic ER4S. It's a very high quality, I guess they call it earbud. It's called a transducer that you plug into your ear, nice and snug. And on the other end of this, I plug in the same music that we're listening to through a phone, an iPhone, whatever you're using, and or pink noise. And I listen to the speakers, and I listen to what's going directly into my ear canal, and I listen to the speakers, and it's amazing what you can detect from this. you may notice that, you know what, that snare drum just sounds like it's a little too far back. What's going on? And you go back and look at the frequency response and you notice, oh, there's a little bit of a sway back in the mid-range. I didn't notice. And then you pull things up a half a dB for an octave and boom, there's a snare drum. So that's what we did. That's the level 400. And you remember, we spent a fair amount of time getting like that final little tuning in.
Yep. We sure did. And it made a great difference, I thought. Now, this was even before the acoustic treatments, which we're going to talk about in the next episode.
Right.
And I remember you actually putting up a blanket or some pad in one spot and saying, how does that sound as opposed to not? Which helped you figure out the acoustic treatments,
right? At
least to some degree.
We did some ad hoc acoustic treatments doing the tuning. Right. Your room, you're probably going there, but you need to know that the whole left wall is a thick drape.
Yes.
There also are drapes on the right wall over the window and drapes on the back.
Correct.
So just naturally, like you mentioned in a recent podcast, the stuff of life is already there to bring the reverb time down or the reflection decay time down to a reasonable level. But you had a big section of wall where there's a strong reflection on one side and not on the other. It's like, well, is this audible? So I think I had you go out and get a yoga mat?
Yes.
Mat? I don't know what you found. You went and found
it was a yoga mat. Yeah.
Yoga mat. So after we did our yoga together and we meditated over the thing, we put it on the wall and do you hear a difference on and off? And we agreed, yep, it was worth doing something to that section of wall, which you did later.
Right. Which we're going to talk about in the next episode. But for now, I think we've covered a lot of ground here, and I sure appreciate you being here to explain all of this to us. And at the end of this episode, why don't you tell us where people can find you?
Yeah. Can I digress for just one quick second about one thing that may not be apparent? So you showed the pictures of where all of your top, side, and back speakers were, and they're all up there.
Yes.
And
you want to see that one again?
Sure. Or do you have any pictures now that the room's all finished that shows?
I do, but I was going to show it next week.
Okay. So those all look like they're on the ceiling, and it should sound like the sound is all up in the ceiling for anything that's not in the front. Did it sound that way to you?
No, and I was going to talk about this next week.
Okay,
but
this is about speakers and not so much about acoustical treatments.
Okay, then I'll talk about it now. A
little bit here. So how come it doesn't sound like it's up there over your head all the time?
Well, please, Professor, answer the question. Why doesn't it sound like that? I wanted to ask that question.
So these speakers, they look like they have a little horn in them, but it's a waveguide. And actually the role of that waveguide is to do kind of the inverse of what you see in most horns. Most horns, their job is to increase the sound pressure level of the speaker and focus the energy forward. Mm-hmm. This is doing the inverse. Its job is to take the radiation output of a tweeter and spray it really wide, more or less plus and minus 80 degrees. A regular tweeter is going to radiate plus and minus 30 degrees. And with this waveguide, we actually splay it out to be much wider. So when you're sitting in your seat over there, you're hit with a little bit of vector or sound directly from the speaker, and then you're hit by a lot of later reflected sounds that are coming from the walls at a lower height. And so it is. I sometimes psychoacoustically, your perception is the sound is lower in the room than where those things are.
Now, that's not going to be true. That reflection off the wall is not going to be true of the side with the curtain.
Of the curtain, correct. So there is enough reflection off the ceiling and other boundaries around that essentially confuse you enough to not feel like it's all up there. That's the thing. A more traditional speaker that would be a regular woofer tweeter without that really wide splaying would give much more of an image that's up there because it's going to energize a lot less of the reflected energy in the higher frequencies where you're sensing where the sound is coming from. And like they say in England, the proof's in the pudding, I guess, how well you cook that pudding. The result is, it doesn't sound like it's all in the ceiling, which is why we take the liberty on the compromises to put a bunch of speakers up there going, you know what? I know that you don't want the entire movie to be coming up from up there, but believe me, it's going to sound like it's lower.
That's right.
Or like that guy.
I don't think it. I would have to say I didn't think it was as low as it would have been if there were speakers actually on the sides.
No doubt about it.
But it's certainly lower down than I would have expected.
Right.
No question about it.
Right. So there it is. Even though you have a big curtain on one side that's absorbing not everything, it's, the highs are still bouncing off that fabric. Even though you have that, the overall sound field in the room, what I call the sound power, the next bubble of sound, is a combination of that sound coming from up plus all the reflections in which the net height is basically between the height of your ear and the height of the speaker. It's at the average, so it's up, it's there. And that works for the surrounds. It also works for the fronts. Once in a while, we're forced to put a center speaker above a big screen, that goes all the way to the ceiling. And we use the same kind of speaker as you have there, the W or the WD, which is the recessed version. And people remark, it's like, I know the speaker's there, but it sort of sounds like it's, rather than coming from the ceiling, it sounds like it's coming from there in the actor, which is still not the ideal thing, which is you'd want it to come from
there. Yeah, right.
It's a reasonable compromise.
Well, and what we decided to do, if you can pull once more the first placement graphic, which is, I'll tell you in a minute, graphic 7, we can see how we place the front speakers. And I just want to mention that a little bit since we're talking about placement here. There it is. We put the front left and right speakers down below where they normally would go. Normally they would sort of be in the center front, top to bottom of the TV screen, but they're down lower. And the installer said, "Really? You really want to do that?" And I said, "Yes, because putting the center channel just below the screen, you want the right and left to be more or less in a line with the center. Now, it's not perfect in this case, but you don't want the right and left to be too much higher than the center, because then you lose that continuity of right to left."
Right. That's an interesting example of how there's in the Rubik's Cube thinking, or the 5,000 piece puzzle thinking of this. There's a lot of effects that affect each other. So you can't look at any one decision in isolation of everything else. So yes, ideally, by the way, the center of radiation of that speaker is just a few inches down from the top of the cabinet. So it's just down a little bit from the middle of the screen. If you only had left and right speakers and not worried about a center, you would put them up a little higher. But like you said, you want a nice continuity when sounds go from left through center to right, or right, through the sound field. You want them to sound not like a smile shape like that, but you want them to be even. So there's a compromise.
Right.
It's the, you have to consider all the factors and go, okay, I'm going to lower those so that the continuity is better.
Right. Exactly. So that's what I explained to him, and he got it. He thought it was okay. Okay. So now, at the end of this episode, tell us where we can find you.
So you can find me either on an airplane on my way somewhere.
You travel a lot, man.
A guy intercepted me at the airport in Munich when I was on my way to the Munich Hi-Fi show last year. A Danish guy who was following me on YouTube, and he was like, "Hey, you're Mr. Grimani." It's like, what did I do? Easiest way is to go to www.grimani.tv, just like my name is spelled there, GRIMANI.tv. That will bring you to the speaker company. If you want to talk about design services, the company is different. It's www.PMILTD.com. That stands for Performance Media Industries Limited.com, PMILTD.com. And then finally, if you're interested in looking at some of the really cool acoustical treatments we're bringing in from Europe, it's a company called Sonitus, which is the goddess of sound.
Very
Sonitus. Nice. So it's the website is actually sonitususa.com. sonit.com, SONIT, TUS.
Yep.
USA.com, and you'll see some really cool acoustical materials there, some of which you ended up using. We'll look at that next week. Some of which there's a ever expanding range of really cool looking things. I'll say this, making an absorber out of a regular piece of fiberglass or rock wool in a square or rectangle, that's easy. You don't need to bring anything from outside the world, but they don't look very pretty. So we're working with this company in Europe that has a great design sensibility at making things that you can put on the wall and make it look like modern art. You know, the best compliment is when one of our clients builds a room, puts all the stuff everywhere, and their friends come over and go, "Wow, I like all the modern sculptures you've put up here."
Right. Good. Well, we will talk about that next week.
Sounds great.
So thanks a lot for being here, and we will see you then.
Great. Thank you so much, Scott. This was fun.
Good. Glad to think so. I think so too. So if you have a question for me, you can send it along to htg@twit.tv, and I'll answer as many as I can right here on the show. Now, recently, TWiT decided to put all of its shows on YouTube, so you can watch them there. But they have commercials. If you want to go ad-free, join the club. Just go to twit.tv/clubtwit, and you can join Club Twit and see all of our shows ad-free. So I hope you'll think about it. Until next time, geek out.